Nicola. I am the founder of f2.net. We are a web development company based in Bergamo, Italy, and we are hiring, so if you want to talk to me later. And I'm the father of Nicola, who is 3 years old, and Julia, who is almost 1 year old, and this is my first talk at an international conference. So, hooks. Who is already using hooks in a new project? Okay, many. Very well. I must say that I wasn't hooked on hook at first, because the first thing that I understood about hooks was that hooks are a way to use states and lifecycle events without using ES6 class components. But in a way, I liked the class components. They were my bread and butter. They gave order to my code, you know, the echo structure, then you have the lifecycle methods, and then the event handlers and the render function. So I felt at home with that structure. But then I discovered custom hooks, and so I understood the second big reason behind hooks, which is reusing stateful logic. And then I was hooked. So today we'll talk about reusing stateful logic. What does it mean to reuse stateful logic? Reuse logic is simple, it's the dry principle. You don't repeat yourself, so abstract and reuse. But what is this stateful logic that requires complex patterns like higher order components to be reused? Let's see first what is not. Well, the first thing that comes to my mind when I think of reusing code is when I take a function and put it into a library, or when I use a function from Lodash. If, for example, if we are lazy and we don't want to implement the debounce using a finite state machine, we can take it from Lodash, and we give a debounce function, and we have back our debounced function. But of course, Lodash knows nothing about React state and knows nothing about React, really. So to reuse just a simple logic, we can just use a JS module. The other thing that doesn't match the kind of problem that we are trying to solve today is the simple component composition, because it is used to reuse UI more than state. For example, here the blue square is our component, and we are using a switch component. This switch component has the typical interface of a controlled component with value and on change. We give it the value from our state, and whenever something happens in the UI that changes the value, we are notified via the onChange callback, so that we can update our state, render based on it, for example, hiding or showing content based on the switch value, and then we pass back the value to the switch to close the control cycle. But you see that the state resides in our component, not in the switch. Even if this switch component was uncontrolled and it had an internal state, so that we passed to it just the initial value, if this switch component wanted to pass to us its state, being it a children, the only way that it has to pass as state is via the onChange callback, so that to render based on the internal state of the switch, we have to take the switch state, put it into our state, and then render it. Instead, with the stateful logic that we are talking about today, the library has an internal state, but the state management is completely delegated to the library, so that the library gives us the state ready to be rendered. So we don't have to set the state, because we receive the state ready to be rendered from the library. For example, with Redux, we want to access the Redux store. If you use React Redux, we subscribe a part of the store, and we have the state available on the props, so that we can render based on them. The same happens with Apollo, which is a library to fetch data from GraphQL APIs. The interesting thing about Apollo is that it implements all the methods that we'll see today, so the higher order components, the render props, and the hooks lately. And the same happens, for example, with Formic, which is a library to manage forms. formic gives us the state of the form and the status of every field, you know, if it's valid, if it's dirty, without having to subscribe all the events of the form. So let's make an example. Here we have a simple, it is legible, do we have to zoom in better? Okay. So this simple application just renders a screen size component, and the screen size component prints on the screen the width and date of the window, keeping it updated as the window is resized. So it's very simple. We have a constructor where we set the initial state to with 0 and 80. Here we have a utility function which takes the width and date and returns an object with this width and date. In component didMount, we set the state as the component mount with the initial width and 8, and then we subscribe the resize event. We add an event listener so that every time the window is resized, the handle resize method is called. The handle resize method just sets on the state the new width and date. And to clean up things, we use a component will unmount event handler so that lifecycle events, so that we can remove the event listener. The render function is very simple. We just print the width and date from the state, and the result is this. Okay. Now, if we want to reuse this logic, if we want to make this width and date available to another component, what can we do? The first thing that may come to my mind is, well, I just render the component here and I pass to it the width and date via props. But we are building a library, so it's our user that will use our library, so we are not in control of its component. It's not our library that will render our user component, but it's our user that will use our library and that will render our components. So we need a sort of inversion of control, and from this inversion of control arises the need for the complex patterns. Let's see them. Here are 5 ways that we can use to reuse stateful logic in React. The first 2 are in gray because we don't want to use them, and we'll see why. And then we have the big 3, higher order components, random props, and hooks. Why I say that we don't have to use inheritance? Well, who comes from an object-oriented programming experience knows that with the inheritance we may have a vehicle class, and then from the vehicle class we inherit a car class, which is a vehicle with 4 wheels and an engine. And then we may have a bike class, which is a vehicle with 2 wheels and no engine. And then maybe we have a motorcycle, which may be a car, but with just 2 wheels, or it may be a bike with an engine. Or maybe we could refactor everything and have a vehicle with engine and vehicle without engine, so that the car and the motorcycle inherit from the vehicle with engine and the bike inherits from the vehicle without engine. So just from this stupid example, you see that creating a chain of inheritance is not future-proof. You have to know very well your domain, and this domain must be very stable, 2 things that almost never happens. So, we say that composition is a better approach over inheritance. So with composition, we just say that a car is made up of 4 wheels and an engine, a bike is made up of 2 wheels, and a motorcycle has 2 wheels and an engine. Thinking in terms of UI, we may think that with inheritance we have a layout, and then from the layout we inherit a layout with the sidebar and a layout with header, and then from layout with sidebar we inherit a layout with the sidebar and 2 buttons, and maybe a layout with sidebar and 2 blue buttons. With React we reason in terms of composition instead. So we have a layout component, and inside the layout component we put an header and we put a a sidebar, and inside the sidebar we put two buttons that via props we say that they are blue. So now, just for one time in our life, we'll use inheritance to share stateful logic. And let's pretend that while I code, there's this sign right here in a corner. Don't try this at home. So, using inheritance is really simple. Here, instead of inheriting from the React components, I just inherit from the screen size component. And here we can just say this dot state dot width and this dot state dot height. How cool is it? Where does this state come from? It comes, of course, from the screen size component from which we inherited. But now suppose that we are releasing this as a library. We should say to our user, don't inherit anymore from the React component, but inherit from our screen size component to have the width and height available. And then maybe another library says, don't inherit anymore from the React component, but inherit from the with router component to have available the router, so that when a user needs both the router and the width and height, it's a nightmare. So inheritance is just not to be used. Let's go on. Mixins. Mixins are a thing from the Jurassic era of React, the era of React create class. I've never used a mixins, but we'll see them quickly because they are interesting and because we all like dinosaurs, right? So, React create class accepted an object with get initial state. We may think of it like the constructor, the event handlers, and the render function. The idea behind mixins was to take a part of this object, put it into a mixin, and then in another component we could use an array of mixins. Mixins had a problem. Really, they had more than one problem, but we are interested in the name collision problem. We could have two mixins trying to set the same part of the state. For example, we may have two mixins with two event handlers trying to set the width on our component. But really, mixins died not because they had this problem, but they died because of a meteorite, and this meteorite name was ES6. Mixins don't work anymore with ES6 classes, and of course they don't work with functional components, so they're just a thing from the past. And now we are with the big three: the good, the bad, and the ugly. So, higher order components, the bad. What is an higher order component? I think that most of you have used higher order functions. An higher order function is a function that returns a function. They come in handy when you want to configure an event handler, for example. In this case, you may think that in the JSX we have onChange equals handle change of ID, so that here this function of ID returns a function of event, which is the real event handler, and the advantage is that inside the curly braces we have available both the event and the ID. Similarly, an higher order component is a function which takes a component and returns a component with superpowers. The superpowers being the feature that the library exposes, so in this case, the stateful logic. You see that if this superpowered component here is a functional component, so the higher order component is just an higher order function because it is a function that returns a function. How does it work? Well, we wrap our components with the higher order component function, and we have back a wrapper component, and we render this wrapper component. This wrapper component, in turn, renders our component, passing to it the superpowers via props. So passing to it the state that it wants to share via props, so that we have our superpowered component. And here you see the inversion of control. We render a component which renders our component. So the steps are, we build a function, this function takes an input component, and then it returns the wrapper component with the stateful logic, and it renders the input component, passing to it the state via props. Let's do it. So we create a new file, which is with screen size. And we said that it is a function. It takes an input component, and it returns a wrapper component. Okay, we have to build this wrapper component. Let's copy the code from our screen size component. Okay. And let's call it wrapper component. We have to import component from React. Okay, and now we said that we have to render the input component, passing to it the state that we want to share. So we return the input component, and we pass to it our superpowers, which are the width and the height. Okay, so let's use it. In our app, we import the width, screen size, okay, and we apply this function to our component. So that's now should have available our width and height on the props. We don't, because we are still extending the screen size component. I told you that inheritance was bad. Okay, and here we are. So you see that using a higher order component is just importing a function, applying it on our component, and then we have the state available on the props. So what are the problems of higher order components? They were explained very well by Michael Jackson in a talk, I think at the end of 2017. Well, the first problem is just the same problem that we saw with mixins, the name collision. Because when we have multiple higher order components, each one may try to set the same prop on our component. So we may have two higher order components trying to set the width prop on our component. And the second problem is that there isn't a clear mapping between the higher order components and the props. So we have a set of props, but if we take one prop, it is not clear which higher order component set this prop. And the third problem is that the composition is static. The composition happens outside of the render function. So if we wanted to configure this higher order component, like you do with the connect from React Redux, here we don't have, for example, the state of the component available because we are outside of the render function. So to recap, the problems of higher order components are the prop name clashing, the who set this prop problem, and the static composition. Well, there is another problem when you have an higher order component, because this code is not so beautiful to see, but we can use the compose function from the functional programming and then apply our higher order component linearly to our components. So it's not a problem. And render props, the ugly. What's the idea behind render props? A render props library gives us a wrapper component, and we pass to it a function, a render function via props. So suppose that there is a prop whose name is render, and inside this prop we pass a function The wrapper component will use this function to render, passing to it the superpowers, the states, as arguments, so that this function can render our superpower component. So the steps here are: we create a wrapper component, and when we render, we call a function that we suppose that the user put in a render prop, and we pass to this function as argument the state that we want to share. Let's do it. We create a new file, screen size rp render props.js, and let's copy our screen size component. Okay, let's call it screen size rp to be more clear. Okay, and creating the render props library is very simple, because we just have to return in the render the function that we suppose that we received on the props. So this dot props dot render, and we pass the width and date as arguments. Okay, so let's use it. We import our screen size rp. We don't need this wrapping anymore, and so we render screen size rp. Okay, this props render is not a function because we didn't pass it, and so it is a function of width and height, and it just returns our width and height. Okay, and it works. Okay, you may have seen this pattern in the form of children as a function. It is just the same thing, but instead of having the function in a prop that calls render, you have the function in a prop called children. You just put it in the children. It's very easy to refactor our code to have the children as a function pattern. Instead of this props render, we suppose that the function is in the children, and so we copy this function here and put it as a children of this component. Okay, you see that it's just the same thing. Lately, the pattern is used more in this way. So, do we have solved the problems that we had with higher order components? Let's check it. We have no more the name collision problem, because here width and date are just arguments of a function, so we may rename them as we want. So no naming collision. And it's very clear where these width and date come from, because they're just the argument of this function. There's no problem understanding where these variables come from. And you see that the composition is done inside of the render function this time. So if we wanted to configure this component passing it some props, let's suppose that this is the query component from Apollo after 2.1 and before the hooks. So if we want to pass variables for the query, we can here pass variables that come from the state of the component, because here we are inside of the render function. So we have solved all of the three problems that we had with the higher order components. Okay, with render props we have no one of these problems. So we can say that render props are a superior pattern respect higher order components. But why did you tell that they are ugly then? Well, when you have many render props components, you easily end up with what is called the wrapper hell. Here you see that with just 2 components, we are indenting 6 levels. And what's worst, this is a false hierarchy, because no one of these components is really rendering something interesting in the DOM. They're just passing down data in the children function. So render props solved the three problems and created a new one, the wrappers hell. Hooks to the rescue. Hook, of course, is the good. So for hooks, we don't need any fancy animation to explain them. Hooks are simple. They are simply functions with some black magic from React behind the scenes, but when you use them, they're just functions. So you import the hook, you execute the function, and as a result, you have the superpowers. So let's write the code. Let's write our custom hook. Let's create a new file. Use screen size. Okay, let's copy once again our screen size component. This time we'll have to refactor it a bit, because you know that hooks don't work with class components, so we need to create a functional component here and refactor the code. So let's do it. Instead of this constructor, we'll use use state, the use state hook from React, so that we may do something like this: const screen size, and set screen size equals use state. So we are not saving the width and the age separately. We are just using a single object, screen size. And so the initial state is an object with width 0 and height 0. Okay, and we can delete the constructor. So this is not a method anymore, but it becomes a simple arrow function. Okay. Instead of component did mount, we'll use use effect, the use effect hook from React. So let's import use effect. And the use effect takes a function and an array of dependencies. Here we want to execute this code just on the first render, so the array of dependencies is an empty array. Let's copy this code here. This set state becomes just our set screen size, and no more this. Okay. So this handle resize to is just an arrow function, and so we can delete our component did mount, and this set state here is just the same as this one. Okay, and to do the cleanup, what we did in component will mount, we can do it now in a return, and in the return of the function that we gave to use effect. So here we can return the cleanup function, which removes the event listener. Okay, and we can delete the component will mount too. Okay, we can delete this render because this is a custom hook, and so what we are returning is state, so our screen size. Usually you see hooks returning an array, but in this case I think that it's sensible to just return an object with the width and the height. Oh, we can call it use screen size, maybe it's better. Okay, so let's use it. So we import our use screen size custom hook. We have to refactor even this component to be a simple functional component because we cannot use custom hooks in a class component. So const app equals, okay, no render anymore, okay. And so we said that using a hook is just calling a function, and so here we just expect an object to be returned from the hook function, and we destructure the width and date from the object returned. And so now we can print width and height. Here we are. So it was a bit long to refactor the code, but you see that when you use the hooks, the hook, it's very simple. You just call the function and you have back the state. And with the hook, we don't have any of the problems that we had with higher order components, because we had no name clashing problem. Here, even if we are destructuring from an object, if we want to change this name, we can simply alias it if we want. And it's really clear where these variables are coming from, because they are the result of a function call. And the composition happens inside the render function here too. So if we want to configure this use screen size, passing something from the state, we can do it. And no wrapping happens at all. Well, there is just one caveat that we cannot call this hook inside of a conditional, because it's one of the rules of hooks. But in general, it's not a problem. I can think, for example, if you have the use query from Apollo and you would like to launch a query only when a condition is met, there is, for example, the skip option from Apollo, so that you can skip the query in some cases. So in general, it's not a problem. So if we wanted to refactor this code to return an array, we can do it easily. Screen size.width and screen size.height. Return the two in an array, and so this time we can destructure from the array. And so renaming the variables is easier, because we don't have to alias. Of course, here is just the order that counts, so we can call it foo if we want. Okay, so with the hooks, we don't have anymore the problems that we had with higher order components and with render props. Yahook. So here is a recap of the ways that we have in React to reuse code. So reuse for using stateless logic. To reuse logic in React. So to reuse stateless logic, we have JS modules and a simple component composition. And for stateful logic, we have inheritance and mixins that we don't want to use. And we have higher order components, the bad, render props, the ugly, and hooks, the good. So you may choose what you want, but after my talk, I hope that you'd like to choose the good. And just 2 words about, to conclude, about when reuse. I often see junior developers, a step back. We are all junior developers for life in this fast-changing world, but I think that sometimes you find ideas that hold true across technology changes, and as you put more and more of these ideas, patterns, tricks of the trade in your backpack, you are on the way to be a senior junior developer. So I often see junior developers who apply the dry principle to the letter. So when they see 2 lines of code here repeated there, they feel the urge to create a new library to abstract to a custom hook, as if repeating 2 lines of code was a deadly sin. And so you have 1 line repeated, but to understand that 1 line you have to open another file. And maybe then you have a third case which is slightly different, and so you start putting parameters on your library and if statements, so that you end up with 30 line of code which are less legible. And maybe you think that it was better to create 2 different abstractions or not to abstract at all. So now you have a new tool, and it's a great tool, the custom hook, but this algorithm is still valid. So repeat your code once, repeat it again, and only when you have understood all the use cases, then abstract. Of course, with a custom hook. And that's all. Thank you very much.